In this lesson, we're going to talk about the three forms of linear equations. I'm going to do a big overview for you so you kind of understand the big picture, and then we're going to dive right into those forms of equations. First, big picture here. A linear equation is any equation, remember, that has a degree of 1. That means the x is not going to have any exponent on it. The y won't have any exponent on it. If you have an equation like that, and the x is in a fraction, in the denominator of a fraction, it's going to be a linear equation. There are three different forms of an equation. These are ways of writing the equation of a line, and we have them represented there. You can look at them on the screen. Remember that an equation is a way of describing the relationship between x and y. Are they dating? Are they talking? Are they married? What is the relationship? Let's define it, ladies and gentlemen. Just kidding. But in the first equation here, it's clear that 2 times x plus 11 is y. That's the relationship between x and y. I multiply x times 2, I add 11, I'm going to get y. The second equation there is actually exactly the same relationship between x and y. It just looks slightly different. It's just rearranged. You notice in the first equation, the x and the y are on opposite sides of the equal sign. And in the second equation, it's still the same relationship. They're just in the same room on the same side of the equation. And then, in fact, the third equation here is the exact same relationship too as the first two. It's the same relationship between x and y. It just looks different. It's rearranged. There's some parentheses thrown in there. These are the three forms of the linear equation and the way they look when you actually put numbers in them. All right, so here's the names of those three forms. First, we have slope-intercept form. The second one is standard form, and the third one is point-slope form. And these are really important for you to know. These are like templates for the different ways that you can write an equation. You fill in information where the blue and gold letters are. That would be the M is the gold letter there, and the B and the Y1 and the X1 are blue letters. You will fill in numbers there. And then the black numbers stay black. On the standard form, we don't actually fill in things for the capital A, capital B, and capital C, but they will be integers, and A is non-negative. So the A, B, and C will be actual numbers, and then the X and the Y and the equal sign will all just stay X and Y and equal sign. Why do we need three forms? Well, because they're all good at something. Each one of these gives us a different piece of information, and you should be able to pick which one you need based on the information you're given in a problem, or maybe what you want to do with the information that you get from the equation. So you should also be flexible thinkers and be able to convert between slope-intercept form and standard form, between standard form and point slope, well, maybe not that way, but you should be able to go point slope form into slope-intercept form. You should be able to do standard form into slope-intercept form and then slope-intercept form into standard form. The most useful thing is actually converting into slope-intercept form, but occasionally you might want to convert into standard form. More on that later. M is always the slope of a problem. So for slope-intercept form, if the slope goes in front of the x, it's the coefficient of x. For point slope form, you'll notice it's also in front of x, but there's a parentheses separating them. B is the y-intercept of the line. X1, Y1 is a point. So both B and X1, Y1 are points on the line. This one is particularly useful when given a slope and intercept. That's why we call it slope-intercept form. It's good for graphing. The standard form is useful for finding X and Y intercepts. And point slope form is useful if they give you a point in slope. It's a useful form to use. In algebra, we graph from each one of these forms. We also use each one of these forms, if you want to think of it as a template, for writing equations. Graphs are useful for showing us a visual of a line, so that's why it's a good idea to be able to graph lines. And why do we need to be able to write equations? Equations are useful because they define the relationship between x and y. Is y twice what x is? Is y equal to half of x? They define a general relationship between x and y. So take a look at this. For example, what rule relates x and y in this table below? Well, in the first pair here, I can see that y is 3 more than x. Okay, so this 4 is 3 more than 1. So maybe the rule is y is 3 more than x. But that doesn't hold true for all the other pairs. 7 isn't 3 more than 2. 10 isn't 3 more than 3. So that's not the rule for the x's and the y's in the table. Y is also 4 times what x is. You see that? 4 times x is y, but that also doesn't hold true for all the other pairs. X plus y equals 5, but that doesn't hold true for all the other pairs. So that can't be the rule that defines x and y here. The relationship is actually y minus 3x equals 1. So 4 minus 3 times 1 is 1. 7 minus 3 times 2 is 1. 10 minus 3 times 2. And you see it's always equaling 1. Or we could rearrange this in a different form and say y is 3 times what x is plus 1. 3 times 1 plus 1 is 4. 3 times 2 plus 1 is 7, and so on. We will explore how to find these equations or the definitions of the relationships between x and y more in future videos, but those 3 forms of the equation that we talked about are what are going to help you to write these rules.